All right, so I will confess that I do not read the entire question. There's a reason I'm a math teacher. I don't read the entire question, and I don't usually read it necessarily in order. Sometimes I actually do read the entire thing, I suppose. But the first thing I like to look for is like, what do they want me to find? So I go to the end first, and then I read it with the end in mind. So how many CDs did he start with? That's the question. That's what I'm looking for. And so I use that to identify what I want my variable to represent. So I'm going to say that X is his CDs at the start. So now that I have in my mind what X is going to represent, and you could use whatever variable you want. It doesn't have to be X, but that's just typically my go-to. Now I'm going to go through the rest and write my equation. So Jason bought 6 CDs to add to his collection. Well, his collection would have been X, the how many he started with. So I can say 6 plus X. And then, a week later, he dropped half of his total collection. Yeah, so we want to divide it all by 2. The whole thing, not just the X, because he's dropping half of the originals and half of the ones. And then, since it's half, if he lost half, he also has the other half left. So, and then what he has left is equal to 12. And so that's my original equation. And then now I need to solve that. Since it's a big fraction, more than one part in the fraction, we're going to multiply first. And so remember here, that just gets rid of that. I don't want to distribute that. It's just getting rid of the fraction. So I have now 6 plus X is 24. Which basically takes us back in time to before he dropped half of them. Now if we get rid of the 6 that he purchased, we find out 18. So I can say then 18 CDs. That's what he started with, 18 CDs. Not $18, not 18 rocks, not 18 days, 18 CDs. How many CDs did he start with? 18 CDs. I have had math teacher friends, and my daughter has had teachers who, and you may have had a teacher who asked you to write a whole sentence. Jason started with 18 CDs. I'm not going to ask you to go there, just 18 CDs. But I do ask that you include that label. So this next one is really an inequality, and there's not really a spot here that it tells you that, other than that at the top of the page it might say that they are equations and inequalities. But it doesn't come out nice and evenly. So I'm going to write this as an inequality. How many snacks can he buy? He has a $5.45 budget total. That includes the money that he's spending on the bus ticket. So that means if it's a budget, and normally I would have done other budget problems prior to this assignment, but he would want to stay under or equal to, and I'll let my X be my snacks, about to not follow my own process, but his spending needs to stay under or equal to $5.45. And then what is he spending money on? He's spending $1.25 for the bus, plus 75 cents for each snack. So notice when I say that X is the snacks, then the 75 cents goes with the X because it's each snack is 75 cents. So we're going to take away the money he spends for the bus. And now I have 0.75x is less than or equal to $4.20. And then when we divide, we get a decimal. Someone have a calculator? Want to tell me what that actually comes out to be? 5 point something. What is 420 divided by 75? $4.20 divided by 75 cents. 5.6. Okay. So now, can you buy 0.6 of these snacks? No. And sometimes people will get in their head like, oh, but it's more than half, so I should round it up. No. When you go to the store, if you have more than half of the money, they don't just like let you go ahead and get another one, right? So notice also the inequality. I said x is less than this number. So he can actually only buy 5 snacks, which would cost him $3.75. He would need $4.50 to buy 6 snacks. So since it's less, we have to round that down. Even if it was 5.99, we still have to round it down. He does not have enough money to buy 6 snacks. He just ends up, going home with 45 cents in his pocket. I think this is the only one that actually sets up as an inequality. All right, next up, I've got some cookies just to make me, I just ate lunch, so I'm not that hungry. So we are looking for, in this case, how many students turn their work in on time. So X is going to be students. And again, I'll mention you can use whatever variable you want. But I personally would avoid using an S as my variable because it looks dangerously like my 5s. And suddenly if I was using S, then it looks like I've got, like in that previous problem, then I would look like I had 0.755, and then it just can get confusing of what's my variable and what's my numbers. And so I usually just stick with X. Occasionally I'll veer off that, but I avoid S because of mistaking it for a 5. So more than one way to write this equation, but I'm going to go in the order that it's given. So the information, I'm starting out with these 56 cookies, and I'm gave 3 to every student, and student is my X, because it's every student who turned their work in on time. So I'm taking away 3 for each student, and after I do that, I still had 8 cookies left. So someone else might have written this equation and written 3x plus 8 equals 56. It will end up being the same. So if I solve this, kind of writing it in the order that I had the information, I would take away 56. Don't forget the negative sign. And I get negative 48. Divide by negative 3. If you forgot the negative sign, then you would divide by a positive 3 and think that the answer was negative, and that would not make sense, even if my cookies were terrible and people were spitting them out. Or these are students, not cookies anyway. So 48 divided by 3 is 16. So 16 students. How many students turn their work in on time? 16 students. I don't require that you do this. By the way, I call that defining a variable. So if you see something that says define a variable as one of the steps, it does not mean tell me the definition of the word variable. It's where we're doing, sometimes people call it a let statement. It's just where you're telling what you're letting the variable represent. But if I've written this, it typically helps me know what my label is going to be also. When we get into systems of equations and we're looking for more than one thing, or actually today even, we're going to look for more than one thing where we only use one variable, then that's going to help us keep things straight also. So next we have Bob, and we want to know how many weeks Bob needs to be on the Subway diet. I'll make this go away. Maybe not. So my variable is going to be the number of weeks that he needs to be on the diet. So he's starting out at 300 pounds. He needs to lose weight. He decided to go on the Subway diet. He was guaranteed to lose 5 pounds a week. So lose is going to be minus 5 every week is my x. So if it was 1 week, we would just subtract 5. If it was 5 weeks, we would subtract 25, and so on. But we want to know, when is it going to be that this would equal 225? So go ahead and solve that two-step equation to find out how many weeks. All right, so I came up with 15 weeks. If somehow you forgot one of those negative signs and you thought it was a negative number, we're not doing time travel to back before Bob ate too much or had whatever, we can't do time travel to get back to that weight. By the way, 5 pounds a week is a pretty lofty goal. To lose 5 pounds consistently every week, probably not very healthy. So just to put that in your ear. Not sustainable probably over 15 weeks to think you're going to keep losing 5 pounds every week. All right, so next up we have James, and we want to find out how many hours. And this is how many hours he needs to work in one day. Okay. So he gets a base pay just for showing up, and then he gets so much for every hour. Be kind of nice if you just got that much for showing up, but so $20 for the day, and he's only working. We're just talking about one day, so the 20 is just happening once, and then the $8 is for every hour. So that's going to be the one that gets our X, because what we're looking for is how many hours. And we want to know if he's going to earn $68. And once again, two-step equation that you can solve. So I'm going to move along a little bit because I'm feeling really confident about your ability to solve two-step equations once we have them set up. I have a theory about why many of my students are not good at word problems initially. I think they all get better. But at least when I was in school, the traditional thing as far as homework was that maybe there was 20 problems that we were assigned to do. Maybe not even 20. Maybe it was do number 2, do 2 through 36 even. So about 20 problems, but only 1 or 2 at the end were word problems. And if you were only doing evens, maybe only 1 problem. And if you got in a hurry, maybe you just skipped that one and you just didn't do it. And it didn't affect your grade a lot because it was only 1 out of the 20 problems. And so people never got enough practice for it to be kind of automatic. And so, as you see from your papers today, we're going to get enough practice and doing a lot of it together repeatedly so that it takes away how intimidating it feels. Right? So, how do you get better at something? You do it more. How do you get over a fear of something? You face it. And so we're going to try to do enough of these that you don't just, word problem, and just shut down. All right? So that it's like, oh, these aren't so bad. It's not that big of a deal. All right? So I'll start stopping after we have it set up because the two-step equation part is not the part that you need more practice in general. That part you guys got down pretty well. But getting it set up. So let's see, number 6. The question asks, how many months will it take? So my x is going to be a number of months. So then as I read back through and I see, well, here's a number, like this is, yeah, so I've got 425, I've got a 545, and then we have each month, it's going to enroll 20. So because this says each month with the 20 is the one that's going to get the X. So our starting number of students is 425. We're adding 20 a month. And we want to know when we'll get to 545. And you could have also written 20x plus 425 is 545. So in this case, that would come out to be 6 months. I believe you all came up with 3 days that Mr. Ryan could stay in Hawaii. And then number 8, most of you are really getting good at writing those equations. Sometimes it's like, ooh, which number goes with the x? That's the big decision, right? It's probably like, oh, equal to 10 for sure. Well, if we remember, like, what are we looking for? We're looking for the hours, so that must be our x. And then I see that it says 40 per hour, so that one has to be the one that goes with the x. You could write the 40x first, you could write the 30 first, but the 30 is that one-time charge, just for showing up at your house. And then 40 per hour. And then now, when we solve this, some of you may have been a little uncertain when you got a decimal. And I understand because I have told you we're not getting into decimals for some other things that we've done. In this case, this is x is equal to 4.5 hours. So, can someone work for just half an hour?
Yes.
Yes. So it's reasonable in this case. If I said, how many students turned their work in on time, and we got 4.5, that would not be reasonable. But in this situation, getting a decimal is not an unreasonable thing. Some of the next questions, in some cases they are easier. There's less application. They are just looking for numbers. Since they're just looking for a number or numbers, then we don't have to, we don't necessarily have to say x equals a number. But sometimes, like we've kind of gotten used to, the other one's like, ooh, where do I even start? So this first one, we have 4 less than twice a number. So less than is what I refer to as a turnaround phrase. It's written in the opposite order than what it's written in words. So twice a number, that's 2x. So I've got 2x minus 4 is 10. So do you see why I called it turnaround? Because less than, we're taking the 4 away from the 2 times x for the twice x. And then is 10, there's our equal. And then, of course, we can solve that to find out that the number is 7. And since it's just a number, you don't need to say, you could say the number is 7, but just 7 is fine. In number 10, we end up with an equation that has multiple steps, not just 2 steps. 3 more than 3 times a number. Remember this a number, that's our x, is 1 less than 2 times the number. So same number, 2 times 1 less than. So 1 less than means we're taking 1 away from the 2 times the number. And then we have variables on both sides. We don't have any distributing to do. We don't have like terms that are already on the same side, but we need to move the variables to the same side. So I'll subtract the 2x to move it over. Then I'll subtract 3. And I get x is negative 4. And you're like, ooh, wait, it's negative. Well, it just says it's a number, all right? Negative numbers are numbers too. Don't be hating on the negative numbers. So, and if we think about this situation, the only way it could be true is if it's a negative number, because we're adding and we're multiplying by 3, and it's going to be the same as multiplying by 2. You know, it's like that can't work for a positive number. Great. The next one, we are actually looking for 3 numbers. We're going to be looking for 3 numbers. And let's just turn the page because I have better examples on the next page for consecutive, even, and odd on one of the following pages. I've pieced together some things here. So if you have a smaller and a larger, like in this case, they start talking about a smaller and a larger, and we're supposed to find these 2 numbers, it is going to be easiest to let x be the smaller one. So I'm going to let x be my smaller number, and then what does it tell me here? It says the larger is 4 more than the smaller. So I can say that x plus 4 is the larger number. Now, I haven't written an equation yet. I've just kind of defined how I'm representing the 2 numbers I'm looking for. That's what I use my first sentence for. In my next sentence, it says if the sum of the numbers is 74. What is sum tell us?
The answer?
The answer to what kind of problem, though?
Addition.
Addition, exactly. So now we're going to say the small one plus the large one is equal to 74. Where this part is the smaller number, that part is the larger. So then we do need to combine like terms. And then after we combine like terms, it's a 2-step problem, 2-step equation. So I'll subtract, and then I'll divide. So when I solve, I got 35, but I'm supposed to have the numbers, not just one number, right? So the numbers are 35 and what's my second number? Well, 70 divided by 2. So 70 divided by 2 is 35. That's my smaller. And then remember what this says over here. The larger one is x plus 4. So now if I do 35 plus 4, my second number is 39. And then I can quickly double check on paper or in my head. Is the larger number 4 more than the smaller? Yes. Do they add up to 74? Yes. Because both of those things need to be true. So your x is going to be your smaller number. So if I let x be the smaller here, then our larger, this one, the larger of the two numbers is 7 less than 3 times the smaller. So 3x minus 7. So 7 less than something means we're taking the 7 away from the something, not something away from 7. And again, we have the sum. So that means we're going to add these together. So the x represents the small number, the 3x minus 7 is the second number, the large number. If we add them together, we get 61. So we'll combine like terms. Then we'll add 7 and divide by 4. Which should get us to x is 17. So my smaller number is 17. And then if I do 3 times 17 minus 7, that's 51 minus 7 is 44. And since I used the 17 to come up with the 44, it should be right that it's 7 less than 3 times. And then just a quick double check, is 17 plus 44, does that equal 61? It does. So the sum is also correct. So we have infinite choices that would add up to 61, especially, if we got into the negatives. But we only have this one pair of numbers that meet both of those requirements of being 7 less than 3 times the smaller and adding up to exactly 61. Okay, before we go further, I want you to turn to the back sheet of paper. It has a number 36 at the bottom. That's going to be the assignment page. And I want you to try number 1 and number 2. I want you to work on number 1 and number 2, not just try. The very back page, like not the back of that page, but the back page of, yes. So it's the one that actually says like, homework 12, word problems. This is a 2-page assignment. So, while this type is fresh in your mind, do 1 and 2. And so this one says the highest score on the algebra test. So we're looking for highest and lowest score. So we did like x is the smallest. Well, smallest would definitely be the lowest score. So I'm going to let x be the lowest. And then now it says the highest score was 42 points more than the lowest. So the lowest is x, and then x plus 42 is the highest. When added together, the highest and the lowest was 154. And then again, very similar to number 1, where we combined like terms and had 2x, then a 2-step. And then finishing up with division. So that 56 is the low. So low score was 56. And then 56 plus 42. High score then is 98. Then we'll turn the page and we will do that problem about Garrett and Liz. Which is a bit like your question with number 3, even though they don't sound, one's about money and one's about time on the team, the setup is still pretty similar. So when you read these, you want to think like who are we referencing? Garrett has blah, 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 as much as Liz. So we're kind of referencing Liz. So even though this question says how much money does Garrett have, we do not want Garrett to be our X. Because if we make Garrett our X, we got to do some really funky things to represent this, like with fractions. So Liz is the one who has the least money. She's the one we're kind of referencing here. So X is going to get to be Liz. And then Garrett, 1 less than, so I'm going to take 1 away from something, 3 times what Liz has. So 3x minus 1, that part is Garrett. And then we have to remember it's together they have that 179, not just Garrett by himself. So we have to make sure we add x plus 3x minus 1 to equal the 179. So now I have 4x minus 1, 2-step equation again. Get lots and lots of practice with that. 4x is 180. Divide by 4. And here x is 45. But that's Liz. And my question, actually, they only are asking me about Garrett. So I need to do 3 times 45. Take away 1. So let's see, that's 135. Take away 1 would be $134. And notice I gave it a dollar sign. So don't just stop once you get x equal. Make sure that your final answer is answering the question. Now, if someone told me, Liz, $45, Garrett, $100, it's okay if you give me more information than I'm asking for, but please don't stop with just Liz in that case. Okay, now we have the Bills and the Dolphins, which I guess the Bills have kind of come back into a lot more popularity with their recent success. So here I have how many points did each team score individually? Well, it says the Bills scored 20 more than twice the Dolphins. So the Dolphins are the ones with the lower score. So I would let X be my Dolphins score. And then the Bills, 24 more than, so 24 plus twice. Or I could have said 2x plus 24 is the same. Together, so we're going to add them together. Together they scored 66 points. So even though my x's aren't next to each other, we know we can combine them to be 3x. And after we've done that, we're right back to the two-step equation. So we can subtract and then divide. And this time it said, how much did each team score? So I've got Dolphins, 14 points, and Bills, I can do 24 plus 2 times 14, or I could just do 66, take away 14. Both ways I better get the same answer, which is 52 points. So number 8 sets up a little differently. We have orange and red Skittles, and it says there are 10 less red than orange, which means orange is the most and red is what we have the least of. So X is going to be my red. And then I could say that X minus 10 is my orange. That's not right. Other way. Well, there's more than there. We have 2 pieces of information here, but that's not the. If there are 10 less red, then so there are 10 less red. That means that my orange is the more. So this would be X plus 10. Or I could say 2x. Now, we don't know the total number. They don't give us a total number. So what they're telling us then, we need that other information too. The orange are also twice the number of red. So I could say 2x, because that's another way to write orange, right? Both of these equal orange. So 2x is equal to x plus 10. We don't have any information about the total number. We just know both of those things are true. And so then if we get our x's on the same side, then we find out that there are 10 red, which means there are 20 orange. And then anytime if I've at all had any hesitation, I especially then want to read back through and make sure it makes sense in the question. There are 10 less red than orange. Okay, I got 10 red, 20 orange. That's true. There are 10 less red than orange. The orange Skittles are also twice the number of red Skittles. 20 is 2 times 10, so we're good. So if I had gotten something mixed up, like if I had left that as being x minus 10, well, if I left it as being x minus 10, I would have come up with a negative number of Skittles, and that would have obviously been ridiculous, not worked. All right, so try 3 and 4 on that back page that you're going to give to me in a bit. And then after you've had a chance to work on those, which may not be quite as similar as our other examples. If you need some help getting them set up, I'll try to help you get them set up. And then we'll be looking at some things with perimeter of a rectangle. 3 and 4 next, yep. On 36. Yeah. You got 3 set up okay, but 4 is there. Yeah. Is that what you said? Okay. Right. I have a feeling there's going to be lots of questions about that one because it's not nearly as similar. Let's see. So 3 is another one where you add them together because it says in total. So that's more similar to what we've been doing. 4 is a little less. I mean a little less similar, yeah. It's a little more like that one with red and orange that the wording can be quite confusing. So let's look at setting 4 up together and then I'll let you finish it after we get it set up. So it says there are 10 less trumpet players than saxophone players, and the number of saxophone players is 3 times the trumpet players. So which one is a smaller number, trumpets or sax? Trumpets, right? There are fewer trumpet players. So I'm going to say that I'm going to let X be my trumpet players. And if there are 10 less trumpet players than sax, if I'm talking about the sax, they would be 10 more. So I could say X plus 10 would be my sax players. Because if there are 10 less trumpets, then going the other direction, we would say 10 more. So now the number of saxophone players, so I could say X plus 10 is 3 times the trumpet players. So there are 10 more of them, and it's also 3 times. And then, like our last example, get your X's on the same side and then divide. And remember, you can put your X's on the right instead of the left. So, and you only have to give me the trumpet players, which is what the X is in this case. If you really like those X's on the left, you could write that equation that way instead. Should be a nice whole number. If you're getting something that's not dividing, that's not a good sign. So for 10, more of the same. W is going to be my width. And then our length, 5 inches more than 4 times the width. So I could say 5 plus 4W or 4W plus 5. And then I'm going to need 2 of both of these. 2 of the width is easy because it's just 2W. 2 of the length, I either need to use parentheses and write it the whole thing twice. But both the 5 and the 4W should be represented twice in there. So all together, let's see, 10 and 8W. Get those W's together. Combine those like terms. Then we've got our two-step equation. We'll subtract and then divide. And we should get W is 8. So 8 inches. Then we have to do 5 plus 4 times 8. So 32 plus 5, 37 inches. And if I add them together and double it, I should get the 90, right? Because there's 2 of each. Question or stretch? Just a stretch. If you get the width and then you're finding the length and it turns out to be a negative number, that doesn't make sense for our application. So that would be like, no, not for this. So we have our width. And then what would our length? How could we write our length in this case? If it is 3
like
less...
Like the width.
Oh, for the next one. How could we, what expression would represent our length?
2W minus 3.
Very good. 2W minus 3. When it's a plus, I could switch the order. If it's a minus, that minus needs to be in front of the 3. I mean, I guess you could put negative 3 plus 2W, but that's kind of awkward. And then, again, for perimeter, it's always 2 of both. 2 of each. So 2 of those widths, 2 of the lengths. And it doesn't matter if you put the 2 of the lengths first. And it is equal to 18. And this one is in centimeters. That just means we're going to change our label at the end. It doesn't change how we do our problem. So don't like, oh, I don't know metric system, I can't do that. No, doesn't matter. It's just the label. So then I distribute it. Oh, I almost distribute it. There we go. Should have waited to see if anybody caught me, but a 6 there, not a 2, or 3 I meant. Not a 2 either. So 2 times 2W, 2 times the negative 3. Combine our like terms. Then a two-step equation. So to get rid of the minus 6, we know we'll have to add 6. And then divide. Came up with 4 then. So the 4 centimeters for the width. And then to find the length, 2 times 4, 8. Take away 3. Gives me 5 centimeters. If I add 4 and 5 together, that's 9. And double it, means times 2, that would give us 18.